Hello there. So in this video, we're going to be talking about literal equations. A literal equation is an equation or a formula that contains multiple variables. And what we will be doing is rearranging these equations or formulas in order to solve for a specific variable. So in past videos, when we've been solving linear equations, we have been solving for a variable and then we get a definitive answer. X equals 3 or n equals -4/7. That's not going to be the case here. We're not going to get just a definitive number to be our answer. Instead, we're going to solve for a variable, and our variable is going to equal an expression that involves other variables. Okay, so let's get into an example so we can see what this actually looks like. Let's start by going back to flowcharts and talking about the story of our variable. What's happening to our variable? So for example, in A, we want to solve 24 plus x equals z. There you see your two variables. We have an x and we have a z. We want to solve this literal equation. We want to solve it for x. So we want to get the x by itself. So what's happening to x? Well, 24 is being added to x, and then we end up with z on the right-hand side. Well, we want to get x by itself now. So in order to get x by itself, we are going to undo what's happening to x. So I'm going to subtract 24, and what I'm left with is that x will equal z minus 24. Okay, or I could have that flipped around and say -24 plus z. So x doesn't equal a number. X equals an expression involving the other parts. Okay, if I wanted to do that without a flowchart, I could see, okay, I want to solve for this x, so I want to get it by itself. What do I have to do? Subtract 24 from both sides, so x is going to equal -24 plus z. All right. Next, we have 12x minus 3y equals -6. In this one, we want to solve for y. So what's happening to the y? What's happening to the y first? Well, first, it's being multiplied by -3, and then it has a positive 12x being added to it. And the end result for that is -6. So now we got to work backwards to see, how do I get the y by itself? Well, the first thing I'm going to do is subtract 12x. And then I need to divide by -3. So what does that look like? Let's do it over here. We're going to subtract 12x from both sides. So we got -3y equals -12x minus 6. Then we need to divide both sides by -3. And I don't want to leave my answer like this yet because I could simplify it further. Remember, if we have a numerator that shares a denominator, we could split that up into two different fractions. Okay? All I did was split that up into two different fractions, and I can simplify this a little bit. So you see -12 divided by -3. Well, I can simplify that. That becomes 4. So that's going to be 4x. And then we've got -6 divided by -3. So -6 divided by -3, that's going to equal +2. So y is going to equal 4x plus 2. Okay? A quick way for you to check this, you can check it just like you would any other linear equation. So every time I see a y, I'm going to substitute in now 4x plus 2. So I'm going to put that off to the side here. I've got 12x minus 3, but instead of y, I'm going to substitute 4x plus 2 equals -6. If I simplify this, we'll see that the 12x's, those cancel out, and I'm left with -6 equals -6, which is a true statement, which means that what I solve for, when I solved for y and got it by itself, the expression it equals, when I plug it back into the original literal equation, everything checks out. Okay, I'm still left with the true statement. That's how you know that you solved it correctly. Okay, so that's going to start this video. Part 2, we will get into some more examples.